As a bit of a recap, there are three different tools that we've looked at so far for designing algorithms. These are hierarchical charts, flowcharts, and pseudocode. All of them have their different uses. Remember, hierarchical charts are useful for identifying the major task and breaking these down into subtasks. Flowcharts are used for giving the flow of data and thinking about individual subroutines, how the data will flow through that program. And pseudocode is high-level English, which is translated easily into programming code to give the programmer an understanding of what the program's about. We know that flowcharts usually have a decision, and the decision box, remember, is represented by the diamond box. Typically, we make decisions using Boolean expressions, and Boolean expressions are true or false, and these happen in selection statements. If you haven't done already, you should understand that decision boxes or conditional statements, if, case statements, etc., usually have a decision. A while, form, repeat also imply decision. So although often it doesn't seem like a decision, there's definitely a decision in there as well. And often that control is passed within the loop to the start or the end, depending on what type of statement it is. Often, any errors that you have in your program are in your decision statements. Have a look at this code. The code is intended to print out every third number in a list, starting with the first one. Will this work? Have a think. We have previously looked at trace tables, but these are used to find out how algorithms work and why they might not work as well. If the program actually contains a loop, there's a helpful technique to put the loop condition as the first column in the trace table, even if other variables have been determined before. Here's an example of a trace table. We've identified the variables n, a and b, but we do have a decision, which is count. Try to complete the trace table. Here are the answers. Did you get it correct? Try the different tasks now on the worksheet and see how well you go. Let's now think about decision points. If you're going to write a program which gives a multiple choice test with 10 questions, each with 4 possible answers. At the end, the total number of correct answers is displayed. Where are the points in the program do you think that we'd need a decision? I want you to write me an algorithm to try and show this. Here is a possible solution. You can see there are 2 decision points in the program. First of all, we've got our for loop. Our for loop keeps going round from 1 to 10. It knows when it's finished its 10 questions, so each time it asks itself a question. Have I made it to the 10th question? If I haven't, I'm going to continue. If I have, I'm going to end my loop. If statement. We can see if the answer is correct. It's going to add 1 to the total. Try task number 2 on the worksheet. Make sure you use Boolean logic. We've also insisted on validation before. Now, this can be a bit harder, obviously, when you're using Boolean conditions, but think about routines to check that the password is correct. What would happen if the user enters an incorrect password? It's a decision and a validation that we're going to have to think about. How many times are they allowed to re-enter their password? On some systems, after 2 or 3 attempts, there's a time limit put on. All of these are validation routines and questions you might include. Try task number 3 on worksheet 4.